electromagnetic spectrum goes from very short wavelength things that we cannot see, like ultraviolet light. We can't. The sun gives off a wide spectrum of light, and only a very narrow portion of that can we actually see, and we refer to those as moving. White light is a sort of broad spectrum, and it's divided into short wavelengths, which we can see, which are blue, through greens and yellows, through to reds, which we can, and these are longer and longer wavelengths. And then on both sides of the let's call it red, green, and blue light that we can see, there are longer wavelengths that are present around us, called infrared, and then there's shorter wavelengths called ultraviolet. And if you can go beyond that, then there's electromagnetic radiation around us in even longer wavelengths and even shorter wavelengths. And in general, if you create a remote sensing device or a sensor, then they can detect things way off into the long infrared and way off into the shorter beyond even ultraviolet. Okay, so what does that mean? It means actually our eyes are adapted to the light that the sun gives off. This is an evolutionary thing. We live in the daylight mostly, and we can see things that are illuminated by the sun. Okay? Some animals see heat, and that's emitted electromagnetic radiation. They can sense or see in quotations. They can see the heat of an animal, and so that's because probably they evolved by living at night when they don't have the sun to illuminate those things. Okay? So and in general, engineers have created sensors which can see heat and can see very short wavelengths like that. A follow-on question to how remote sensing devices or Earth observation devices can see beyond what we can see in the red, green, and blue is the near infrared and the thermal infrared. Near infrared is reflected long wave energy. So the sun illuminates an object, and some of that energy is in wavelengths longer than we can see with our eyes, but it's reflected from the Earth's surface or from plants and so on and so forth. Healthy plants reflect a lot of near infrared imagery, or near infrared energy. This is different from heat. So this is reflected near infrared. You go into longer wavelengths, that's heat. Objects around us emit a certain amount of energy because they have a temperature. Okay? So, and this is how we detect whether people are sick or not by infrared detection. This is the amount of heat that's being given off. Let me come back to the plant matter around us. Stress vegetation is a poor reflector of near infrared energy. And so in so doing, by detecting energy in the near infrared, we're able to distinguish between healthy plants and not so healthy plants. Super important for agriculture, for forestry, and other remote sensing applications or observation applications that are detecting the natural environment.